Introduction to classes of programming languages. Programming languages are tools that allow us to communicate with computers to create software applications, websites, games, and more. Over time, different programming languages have evolved to cater to various needs, resulting in different classes or categories. Understanding these classes helps in choosing the right language for a specific task. Low-level programming languages. Low-level languages are closer to the hardware of the computer. They provide little or no abstraction from the machine's instructions, which means they are highly efficient but difficult to use. Machine language is the most basic low-level language. It consists of binary code, zeros and ones, that the computer's processor can directly execute. Each machine language is unique to a particular type of CPU. For example, the code that works on an Intel processor won't work on an ARM processor. Assembly language is slightly more abstracted but still very close to machine language. It uses mnemonic codes, like add for addition, sub for subtraction, instead of binary, making it somewhat easier to write. However, it is still complex and requires a deep understanding of the computer's architecture. Use case example. Assembly language is often used in embedded systems and device drivers where efficiency is crucial and the hardware is limited in terms of processing power and memory. High-level programming languages. High-level languages are more abstract and closer to human languages. They are easier to learn and use, as they hide the complex details of the computer's hardware from the programmer. Procedural languages are a type of high-level language where the code is organized into procedures or functions. These languages focus on a sequence of actions or commands to be executed. Examples include C, Pascal, and Fortran. Use case example. C is widely used in developing operating systems like Linux because it allows fine control over hardware while still being easier to write than assembly language. Object-oriented languages are another category of high-level languages. In these languages, code is organized around objects, which are instances of classes. A class is like a blueprint that defines the properties, data, and methods functions that the objects created from it will have. Examples include Java, C++, and Python. Use case example. Java is commonly used for building enterprise-level applications, such as large-scale banking systems, because it promotes code reuse and organization through its object-oriented structure. Functional languages are high-level languages that focus on mathematical functions. In functional programming, computation is treated as the evaluation of mathematical functions and avoids changing state and mutable data. Examples include Haskell, Lisp, and Scala. Use case example. Haskell is often used in academic research and projects that require complex mathematical computations thanks to its ability to handle functions efficiently. Scripting languages. Scripting languages are usually interpreted rather than compiled, meaning that they are executed directly from the source code by an interpreter. They are often used for automating tasks, manipulating data, or adding functionality to web pages. Examples include Python, JavaScript, Ruby, and Perl. Scripting languages are known for being easy to learn and quick to use for small tasks. Use case example. JavaScript is essential for web development because it allows developers to create interactive features on websites, such as forms, animations, and dynamic content updates. Declarative languages. Declarative languages focus on the what rather than the how. Instead of providing step-by-step instructions, the programmer describes the desired outcome, and the language's underlying system determines how to achieve it. Examples include used for database queries, HTML, used for structuring web content, and Prolog, used for logic programming. Use case example. SQL is extensively used in database management systems to retrieve and manipulate data, making it a cornerstone in applications that rely on databases like customer relationship management, CRM software. Domain-specific languages. Domain-specific languages are specialized languages designed for a specific domain or industry. They are not meant for general-purpose programming, but for solving particular types of problems. Examples include R for statistical computing, VHDL for hardware description, and MATLAB for mathematical modeling. Use case example. R is widely used in data analysis and statistics because it provides a rich set of tools and libraries tailored specifically for these tasks. Conclusion. Understanding the different classes of programming languages helps in selecting the right tool for the job. Whether you need the speed of a low-level language, the abstraction of a high-level language, the ease of a scripting language, the expressiveness of a declarative language, or the specificity of a domain-specific language, each has its strengths and ideal use cases.